Let's discuss question number 44 from test 11. This says from thermodynamics. So the volume of the moist air with 50% relative humidity is isothermally reduced to half its original volume. So this is a case of moist air. Now one important thing is that we can assume vapor as an ideal gas. This is a common assumption in moist air. So because it's cooled isothermally reduced to half its original volume. So initially, let's say the vapor pressure is PV into volume is V1 is equal to mRT. Now the new pressure is PV new, volume is reduced to half its original volume P1 by 2, mass is same, temperature is also same. Okay, because we don't know whether mass is same, something has condensed or not, so we assume that mass is change same. Okay, because it will condense only when the relative humidity crosses 100 and initially it is 50. Okay, so if I divide these two, the initial vapor pressure by final vapor pressure into V1 by 2, so that's V1 by 2 and right side is half. So from this I get PV new is twice PV old. Okay, this is what I get. Now relative humidity initially is the vapor pressure by the max vapor pressure at that temperature. So PV by PV sat at that temperature. Okay, and so this was 50%, which is 0.5. Now the new relative humidity is the new vapor pressure by the PV sat at the same temperature. The temperature is not changed, so PV sat, the denominator will not change. Okay, now PV new, we know that it's twice of PV by PV sat of temperature. Now PV by PV sat is the initial relative humidity, so 2 pi 1, and initial relative humidity is 0.5, so this is 1, so it's basically 100%. So the answer for this is D. The relative humidity has increased to 100%. Answer is D. Thank you.